This is a video from the Chapter 8 review. We're going to look at problem number 10. It says, find the length of the curve y equals 2 natural log of sine of 1/2 x, where x is greater than or equal to pi over 3 and less than or equal to pi. So to be able to find the arc length, right, we need to know dy dx. dy dx equals 2 times 1 over sine of 1/2 x times cosine of 1/2 x times the derivative of 1/2 x, which is equal to 1/2. But if you notice, the twos cancel, right? And what we have left is cotangent of 1/2 x. Remember, cosine of 1/2 x divided by sine of 1/2 x is cotangent of 1/2 x. So L is the integral from pi over 3 up to pi of the square root of 1 plus cotangent squared of 1/2 x dx. But 1 plus cotangent squared of 1/2 x is cosecant squared of 1/2 x. So this is the integral from pi over 3 up to pi of the square root of cosecant squared of 1/2 x dx. Now, we have to be careful here, right? Now, I want you to notice something. X is wedged between pi over 3 and pi. Multiply through by 1/2. So 1/2 times pi over 3 is less than or equal to 1/2 x, which is less than or equal to 1/2 times pi. So pi over 6 is less than or equal to 1/2 x, which is less than or equal to pi over 2. And we need to know something about 1/2 x. Now, why would you ask? Now, look, we know that sine of 1/2 x is positive on the interval let's remind ourselves, it's pi over 6 to pi over 2. But cosecant of 1/2 x is the same as 1 over sine of 1/2 x, right? And so, therefore, cosecant of 1/2 x is also positive on the interval pi over 6 to pi over 2. And so, why do I need to know that? So when I take the square root of cosecant squared of 1/2 x, I don't have to put absolute value bars around cosecant of 1/2 x. That's why I need to know that. So this is the integral from pi over 3 up to pi of cosecant of 1/2 x dx. Now, let's give ourselves some room. So we have the integral from pi over 3 to pi of cosecant of 1/2 x dx. So I'm going to let u equal 1/2 x. du is 1/2 dx. Solving for dx, I get dx is 2 du. Now, when x equals pi over 3, u equals pi over 6. And when x equals pi, u equals pi over 2. And so this is the integral from pi over 6 up to pi over 2 of cosecant of u, right, du, but remember we have that 2 on the outside, like that. And so this is 2 natural log of the absolute value of cosecant of u minus cotangent of u evaluated from pi over 6 up to pi over 2. Now, let's plug in our info. So this is 2 times the quantity, natural log of cosecant of pi over 2 minus, let's remind ourselves, cotangent of pi over 2, right? Minus natural log of cosecant of pi over 6 minus cotangent of pi over 6, like this. Now, cotangent of pi over 2 is 0. And so cosecant of pi over 2 is 1. So this is 2 times natural log of 1 minus 0 minus natural log of. Now, cosecant of pi over 6 is 2. Cotangent of pi over 6 is square root of 3. And here, I'll address that shortly. So I claim you're going to get 2 minus square root of 3 for that second number. Now, how did I know that? I took cotangent of pi over 6 and I wrote it as cosine of pi over 6 divided by sine of pi over 6. So this is square root of 3 over 2 divided by 1/2, right? And so this is square root of 3. So that's what we did. And natural log of 1 is 0. And so my final answer is -2 natural log of 2 minus the square root of 3. And you might go, well, wait a minute, isn't that a negative number? Well, no, because if you put 2 minus square root of 3 in your calculator and take the natural log of it, you should get a negative number, and then that negative number times -2 is a positive number. So I'll perform that calculation really quickly here. If I take 2 minus square root of 3, I get 0.27 roughly, right? And I'm going to take natural log of it. So in other words, if I take natural log of 2 minus square root of 3, let's close the parentheses here and hit equals, that's -1.3 something. And if I multiply by -2, I get roughly 2.6. So that is indeed a positive number. So, okay, that'll conclude this video for the Chapter 8 review. And this is problem number 10. Thank you.